Let's practice A for section 7.7. We're going to solve the right triangle. We're going to round our decimal answers to the nearest tenth. Again, I usually do hundredth. So we'll do a few of these together because once you know how to do one of them, you kind of get the idea. If you're solving the right triangle, you need to find everything. So they're going to give you a right triangle, obviously. They're going to give you one acute angle and one side, or maybe two sides. So two pieces of information mean that you're going to have to solve for three things. In this one, you're solving for an angle that's missing and then two sides that are missing. And the idea is to use the two things they give you to find those three things. So it's like three problems in one. The easiest thing to do, if they give you two angles, you know what the other angle is automatically. 180 minus 90 minus 45 is 45. Use this 45-degree angle and this hypotenuse of 12 to find these legs. So I'm going to say, let's just say that's x. In relation to this angle, that's the opposite, that's the hypotenuse. So you're going to use sine. Sine of 45 equals opposite over hypotenuse. Now remember, this is a 45, 45, 90 triangle. You should know that this is 6 square roots of 2. Okay, but we'll use sine here just because we already have it written out. So x is going to be 12 sine 45. We'll type that in. It's going to give you 6 square roots of 2, but the decimal version of it. See that? So we'll call it 8.49. Now that you know this length, you can find the others using that if you wanted to, but you got to watch. You should use the exact answer to do that. Don't use this because this is a rounded answer. If you use a rounded answer to calculate something else, that answer that you find is not going to be accurate. Okay? 45, 45, 90 triangle, so obviously this is the same length. You don't need to do the same work or similar work again. Number 14, this time they give you two legs. If you know two legs, you definitely know the third leg. Remember, third leg. You know the hypotenuse. Right triangles don't have three legs. Okay, so we're going to take the square root of 12 squared plus 17 squared. That's your hypotenuse length, 20.81. And that's rounded, so don't use that to calculate anything else. Use the two things they gave you to calculate whatever else is left. Okay, so for example, let's say we want to find angle P. I'm going to use tangent because I have the opposite leg and the adjacent leg. So tangent of angle P is 17 over 12. Anytime you want an angle measure, just like we did in that previous exercise, you're doing inverse. So inverse tangent 17 over 12. That gives me 54.78. And that's in degrees. Now I know that this angle over here is also inverse tangent, but it's going to be the reciprocal of this. So I could just type in inverse tangent of 12/17, and that gives me 35.22. So that's using the math from this section to get the answer. I didn't have to do this. I could have done 90 minus that to get this same number, right? 180 degrees in a triangle, so these two acutes have to add up to 90. You could have done that instead. You don't have to use all the math that we learned in this section to do these. You can use anything you want. Let's do one more. I guess I'll do 15. And they gave us a hypotenuse. We did that one there too. Let's do one where they give us a leg. Let's do this guy. That's 90, that's 50. I automatically know that's a 40-degree angle. Let's find our hypotenuse, so I'll call it h, and let's find our adjacent leg. So I'm going to use this 50-degree angle. So I'll call that the adjacent leg. I have this angle, I have this opposite, I have this adjacent. So I'm going to use tangent. Tangent of 50 equals 21 over lowercase a. Solve for a. You're going to do 21 divided by tangent 50. That gives me 17.62. That makes sense to me. That's the bigger acute angle, so that's got to be the longer leg. That's the shorter leg. Let's find the hypotenuse. We have the opposite. We want the hypotenuse. So that's sine. So we're going to do sine of 50, and that's going to equal 21 over your hypotenuse. So I'm typing in the same exact thing that I just did, except I'm typing in sine instead. And this is my hypotenuse, so it better be the biggest side length, 27.41. That's how you solve right triangles.